Hi, and welcome back to our channel Neurabytes. My name is Navjinder Virdee, and in this lesson, we will go through our first interview coding question for linked list. Our first coding question is reverse a linked list. This question has been asked in various tech companies such as Microsoft, Adobe, Goldman Sachs, Cognizant, and VMWare, and many more. First, let's understand our problem statement. We will be given a linked list and our task is to reverse the linked list. Let's understand the problem through some examples. Let's say we are given the following list. After applying the reverse operation, the list will look like the following. So from 1, 2 and 3, the list becomes 3, 2 and 1. Let's go through another example. Let's say we are given the following list. Then after applying the reverse operation, the list will look like the following. So head where it points to node 10, now it points to 20, then 20 to 12 and 12 to 10. Let's go through last example. Let's say we are given a single node only. Then after applying the reverse operation, the list remains the same. Let's learn how to solve this problem. If you want to think about a solution, then pause this video right now. Let's say we are given the following list. We need to reverse these pointers so that they point to the previous nodes instead of the next nodes. Let's say somehow we reverse the list up to node 2. Now we are at node 3. That is, our current node is 3. We need to change this pointer to point to node 2 instead of node 4. But how do we get to node 2? We can only move in the forward direction, not backwards. Therefore, we need another reference which will point to the previous node. Let's call it prev. Now we can change the current.next to prev. But if we do that, then we have lost the connection with the rest of the list. So how do we reach node 4 now? Therefore, before changing the current.next, we need one more reference which will point to the next node. Now we can change current.next to prev. Now we need to move one node forward. We can do it by changing prev to current and current to next. That's it. We need to repeat these steps for each node of the list. Let's go through with one full example with these steps. Let's say we are given the following list. Initially, we will assign head to current and prev will be none. So the current reference will point to the node 1 and prev will be equal to none. Then we will follow these 4 steps for every node of the list. First, we will create a next reference and point it to current.next, that is node 2. Then we will change current.next to prev, that is none in this case. Then we will move one node forward by changing prev to current and current to next. And we will keep on repeating for each node of the list. First, we will create next reference and point it to current.next, that is node 3 in this case. Then we will change current.next to prev, that is node 1. Then we will move one node forward by changing prev to current and current to next. Create a next reference and point it to current.next, that is node 4. Then we will change current.next to prev, that is node 2. Then we will move one node forward by changing prev to current and current to next. Again, create a next reference and point it to current.next, that is none in this case. Then we will change current.next to prev, that is node 3 in this case. Then we will move one node forward by changing prev to current and current to next. Now current becomes none, so we have reached the end of the list. Now final step is to change the head reference to point to the last node, which can be done by head is equal to prev, because prev is pointing to the last node, that is 4. Now head refers to the node 4. There you go. We have successfully reversed the linked list. Alright, now let's implement the function. The first case is if the list is already empty or the list contains only a single node. Then in this case we will not perform anything and just return the head. The second case is if the list contains more than one node. Then we will create current node and assign head to it, and also prev and assign none to it. Then we will go through each node of the list and perform the 4 steps. First, we will create next reference and assign current.next to it. Then we will change current.next to point to the prev node. And then we will move one node forward by changing prev to current and current to next. So these are the 4 steps. In the end, we will change the head reference to point to the last node using prev. And finally, we will return the new head. So this was our function. Now let's check it out. First, we will print the initial list using the traverse function. Then we will reverse the list. And finally, we will print the reversed list. So as you can see, the initial list is 50, 40, 30 and 20, and the reverse linked list is 20, 30, 40 and 50. So we have successfully reversed the linked list. Now let's go through the time complexity of the reverse function. The time complexity of reverse function is linear in terms of the length of the list, where n is the number of nodes in the list. This is because we have to go through each node of the list individually and change the pointers. Thank you for watching. In the next lesson, we will go through some other interview coding questions for linked list. If you liked the video, then please like, subscribe and share. And I'll see you in the next lesson.